LeChatelier's principle states that if you have a reaction equilibrium and you apply a stress to that equilibrium, the reaction will shift in a direction in order to relieve the stress. We will look at a series of different reaction equilibria. We'll apply a stress to those equilibria and see in which direction they shift. In the reaction between iron plus 3 ion and thiocyanate ion, if we add some iron plus 3 in the form of iron 3 nitrate, and to the iron 3 nitrate add some potassium thiocyanate, the two react to form a reddish-orange complex ion. We fill 2 test tubes with the reaction mixture. We're going to keep one test tube as a control so that we can see what happens to the color. To the other tube, we're going to add some 0.1 molar iron nitrate to increase the concentration of the iron. We see that there's an increase in the dark red color. This indicates an increase in the concentration of the complex ion. This also indicates that the reaction has shifted in the forward direction. As you add reactant to an equilibrium, the reaction shifts in the direction to use up the added reactant, in this case the forward direction. Now we'll add 0.1 molar potassium thiocyanate to the second tube. This increases the concentration of the thiocyanate ion. We see that the reaction mixture turns a darker red color, indicating an increase in the formation of the complex ion. We've added the other reactant, the thiocyanate. The reaction shifts in the forward direction to use up the added reactant. We will now add some 1 molar sodium hydroxide solution. We notice that the red color decreases significantly. This indicates that the reaction equilibrium has shifted in the reverse direction. The hydroxide ion precipitates the iron ion, effectively removing it from the solution. The equilibrium shifts in the reverse direction to try and increase the concentration of the iron. We will now add solid potassium chloride to the solution. We notice the decrease in color indicating that the reaction has shifted in the reverse direction. The chloride ion forms a complex ion with the iron, effectively tying up the iron concentration. The equilibrium shifts in the reverse direction to try and replace the iron that's been removed. We will now add 0.1 molar silver nitrate to the reaction mixture. We notice the disappearance of the red color, which indicates that the equilibrium has shifted in the reverse direction. We also see the formation of a small amount of white solid. The silver ion reacts with the thiocyanate ion to form slightly soluble silver thiocyanate, which is the white solid. The silver ion removes thiocyanate from solution. The equilibrium shifts in the reverse direction to try and replace the thiocyanate ion that's been removed. We will now add some 0.1 molar mercury 2 nitrate. The mercury plus 2 ion reacts with the thiocyanate ion to form a new complex ion. This effectively reduces the concentration of thiocyanate in the solution. The equilibrium shifts in the reverse direction to try and replace the removed thiocyanate. Take a test tube containing the equilibrium mixture. The solution is pink, indicating that we have a high concentration of the cobalt water complex ion. We're going to put this into a warm water bath. As we warm the solution turns from being pink to blue. If you heat an equilibrium mixture, the equilibrium will shift in the endothermic direction. This is an indication that this reaction is endothermic in the reverse direction. Cooling a reaction mixture shifts the equilibrium in the exothermic direction. we notice that as we cool this, the solution goes from being blue to pink, indicating that the reaction is exothermic in the forward direction.
Final test now is to put our test tube 4, which is favoring the pink side, and I'm bringing an infrared thermometer to show you that the room or the board behind you is 25.5 degrees Celsius, and the water I'm bringing here is 76 degrees Celsius. So I'm going to use a hot bath, and in this test we're going to put the test tube 4 in the hot bath, and we're going to see what kind of color change will happen. Now we're changing the temperature here, so we're actually going to shift not so much the equilibrium. In truth, we're actually changing the equilibrium position to favor one side or the other. By adding heat, okay, we are definitely shifting the equilibrium to a new position that's favoring, if you can see, the blue cobalt chloride complex. All right, and that tells you something about where the heat is. You know something about LeChatelier's principle. You increase the temperature, the reaction is going to shift to always do the opposite. Its response is opposite. So it looks like it's shifting in response to increasing the temperature, which means it's trying to probably relieve that temperature. And this should tell you where the heat is in this reaction. Okay, is the heat go on the reactant side or the product side? One of the questions in the lab, okay, is to find out whether the forward reaction is endo and exo, and right here these tests are telling you. All right, so in my second test I'm going to add a cold water bath, and this test would also support my understanding. So here I have my infrared thermometer. I get about 9 degrees of my ice bath here, and I put my warm solution back into the ice bath, and we can probably guess what's going to happen here. And lowering the temperature, the reaction is going to shift to do the opposite, probably to increase the temperature. So it's going to favor whatever shift of equilibrium that favors the increase in temperature, or the exothermic way. You should know decreasing the temperature is the stress. The reaction is going to change its equilibrium to do the opposite, and that hint of what's happening here should tell you from the ice bath test and the hot bath test where the heat goes in the reaction side. Is the forward reaction exo, or is the forward reaction endo? All right, and we can clearly see that the cold water bath made and shifted the equilibrium to favor the red complex. All right, and that's essentially this lab. From these tests, independent tests, you should be able to figure out where the shifts have occurred and who is increasing and decreasing, and definitely whether the forward reaction is endo or exothermic. All the players involved are taking their bows here. I guess I left the water out. Hope this helped.